So exercise 1031 is asking you to be pretty creative. The only molecule you're allowed to add in this one is acetylene. Now in the previous video, we saw many times how you can do alkylation with acetylene. But in each of those cases, we were always allowed to add whatever carbon chain we wanted to. For example, in this previous one, we added this weird carbon chain. Well, in this exercise, we're not allowed to add any weird carbon chains. Anything we use, we have to make from acetylene. So our goal here is to turn acetylene, using only acetylene molecules as your source of carbon, into 3-hexyne. Now remember, 3-hexyne, you have the triple bond here. It starts on carbon number 3, and therefore goes to carbon 4. So here you have 2, 1, and 5, 6. So that's 3-hexyne. Okay, well, look at this in units of 2 carbons. Acetylene, after all, has 2 carbons in it. So we have this in the center already made, no problem there. What we have on the ends are 2 more carbons. Now really, if we were sort of thinking of this using the method that we learned in the previous step, we could take sodium amide, and that strong base would rip a hydrogen off of here. So you would have a carbon nucleophile, and then we'd look at the carbon chain that we'd want. And here we have 2 carbons in that carbon chain that we want, and we just put a leaving group on it. And then this reacts in an SN2 reaction. This attacks that carbon and kicks the leaving group off, so that ultimately you add the 2 carbons on that end. Oops, like that. Well, that would all be fine and good, except we can't just use this as a source of carbons. All of our carbons have to come from acetylene. So if we're going to use this, we have to make it from acetylene. So how can we take acetylene and turn it in to this molecule here? Well, you can see that we're getting we have the same number of carbons, but you don't have either of the pi bonds. Now, you also see that you have just one lonely halogen. So it might be tempting to add a hydrogen and a halogen, but remember, if you do that, what you get is this here. Okay, well that's not so bad. We could still turn that into our final product by using hydrogenation. So hydrogen, platinum, palladium, or nickel. Just one of those 3. So that's one possible way you can make that. You could have also done it in reverse. You could have said, okay, well, I could just get rid of one of the pi bonds first by doing hydrogenation. So for example, not just regular hydrogenation, that would take you straight to the alkane, but either hydrogenation with Linthar's catalyst or dissolving metal reduction. That would give you a double bond, and then you can treat the double bond with HBr. So you can do these, you can either do the hydrohalogenation or the hydrogenation in either order. You just have to be careful that you don't use excess of this, and that if you do the hydrogenation first, you just take it to an alkene and not straight to an alkane. So you can do one of those reactions to get this here, and once you have that, it's the same exact reaction as before. We use it to create the molecule on the right, then we rip the other hydrogen off there, using a strong base like sodium amide. We have our carbon nucleophile. We just look at the carbon chain that we want. It's 2 carbons, put a leaving group on it. That's what we made down here from acetylene. And so that carbon chain attacks the carbon and kicks the leaving group off, and you end up with your product. So this one was asking you to stretch your mind a little bit in terms of, this process should seem really familiar after the previous video. But it was asking you to stretch your mind a little bit in terms of using the other reactions in order to create these carbon chains that you're adding. You could see that you could create those from acetylene using other reactions from this in the last chapter.